Yeah, so this is the data, and like for example, a case ID, the first column, which talks about some unique identifier for the particular survey, 112, and the same value is repeated over here. As TL is for Timor Leslie, 7. This is a country code. Then it talks about one is the region in which the survey was done, the street lane number, and then the house number. And this is some unique numbers over here. So if you go with this, like the year is mentioned over here, talks about the month and year, the information is complete or not. Um Basically, so basically just this column talks about the area and the basically the state, either it's a rural or urban area. Yeah, so yeah, so basically, like you see, going with this data as a raw data, it talks about like so here's this column, probably might be easy to explain. So it talks about the kind of the property they are living in, either they have got earth or sand or the ceramic tiles over there. What's the texture of the walls, what's the texture of like the ceiling, basically the description of basically the house in which they are living, their religion, uh, yeah. And yeah, so basically, like if you see the column size, I would say at the bottom, yeah, 5,300 columns are there. And if you see here, NAs, so lot of columns have just got NAs, or basically a null value, which I talked about. The nulls are of no use for the modeling or the data analysis. So these columns could be dropped, and that's why we basically dropped them and kept out of study for these like such columns. Yeah. Does this answer your point, Vishal?
Yes, Aniket.
Yeah. And about the plots which we have produced, if I go on this one, so yeah, for example, like living. Oh, sorry. This is about the living environment. So the columns, the important columns on the living environment basket. So living environment, the column which came up very significant, I would say, which was some use in the model, would be the drinking source versus the lung disease. Now again, the color coding is this, such that blue color over in the chart is called talking about the person who has got the lung disease, and the orange color is talking about the person who has not have- sorry, orange color is for person who has got the lung disease, and blue is person who has not got the lung disease. And the values over in the bottom are talking about the type of drinking water or the source of the drinking water they are using. So somebody is using the rainwater or the protected well water. And if you see the unprotected spring water, if person is drinking the unprotected spring water, then out of all those people who are drinking the unprotected spring water, 9.5% people has got a lung disease. Now this data set which we started with is a biased data set. Bias would means out of 2000 records are which we are studying, only 40 people have got a lung disease. So this is a very natural case, and most of the business applications you'll see the data is skewed or biased would mean out of 100 people, only very small percentage would be saying yes to something. So for example, if there is a business case of finding a card fraud, so out of millions of card transaction, only few hundred will be marked as fraud, because fraud is not happening on a scale of 50% or 60%. So fraud is happening on a scale of 0.01% or 0.02%. So that's why out of 1,000 you will only see 2 or 3 or 5 cases where a fraud has happened. And same is happening for the lung disease as well. So out of 2,000 people, only 40 people have got the lung disease. And therefore, because only 2% have got the lung disease, 9.5% of people who are drinking the unprotected water, means this is a significant variable which can help us in finding the the factor, or basically a cause for having a lung disease. And that's why when I talked about the scorecard, drinking water is also being depicted as an important variable, and it has got some statistical importance and the probability to relate it with the lung disease. Cooking fuel, you see there is 38 people who is using the wood as a cooking fuel has got the lung disease, but this is 38 is out of 1566. So the percentage wise this variable is not coming out important, and that's why wood as a fuel is not part of the scorecard. Another important thing which I should mention is here, see, every variable can be somehow used in a model. So model do not know which variable to use, which variable do not to use. Model might be able to increase or decrease the importance of a particular variable, saying if okay this variable is important, I need to find out this is important, and that's why I will give the priority to this variable. So model might have used the cooking fuel as one of the predictors to find out the lung disease, but the weightage given to this particular factor is not high, and thus we have chosen only the top 6 factors to produce a comprehensive guide or a scorecard to 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 easily intuitively find out a person has got a lung disease or not, right? So yeah, so this is how the charts are prepared, and this is why the basically the charts are prepared, so that you can understand which variables are actually relating to the problem you're looking for, right? Any other question, anyone? No. So I've moved to the another point where we were talking about the about the statistics, and we wanted to know what to study in statistics and probability. So I've shared a book onto the WhatsApp group. So that I would say covers a lot of statistics, and it's a long book. So I would not believe basically I will not believe that you will read whole of the book in one go. But and a good place to learn the statistics would be a Khan Academy. So I'll recommend going to the Khan Academy with the website I'm showing on the screen right now. Now this Khan Academy has got a module within maths called statistics and probability. So within the statistics and probability, whatever the subject contains, I would say everything is important for your analysis, or basically the learning from the data science point of view. So either be it's analyzing categorical variables. So see, I would try to map all as much as I can with the case study or the previous session which we have gone through. So here we are analyzing the categorical data. Categorical data is something which is we just talked about as our predictor in our case study. Either person has got a lung disease or not. So it says about categories, yes or no. So that's the categorical data. So you need to analyze one categorical data maybe by different methods. So this module will be talking about those. How do you explain a categorical data? What is the categorical data? Uh, how tabularly or maybe graphically you are able to represent the data. Displaying and comparing quantitative data. So quantitative data would be something related to a continuous variable where we talk about something like the price of air ticket, airline ticket, or a height or a weight. So previously the previous chapter was talking about the categorical data. The another type of data is quantitative data. Same thing being described over here for quantitative data. Then we go to summarizing qualitative data, quantitative data. So in summarization part, it might be talking about the how the spread of the data is, what's the mean, median, mode, the central tendency for the data. Interquartile range is something like what is the percentile or basically the quartile. So quartile 1, Q1, Q2, Q3, which is if you divide the data into 4 parts, where your mid part of the data is, where is your quarter 1 of the data is. So which side of the data is being basically driven through it. So summarizing the data, very important. How do you summarize the data? Uh, then modeling data distribution. So data distribution is something where you will study about how the data is distributed across the different values it can have. To reiterate, if say we're talking about the height of the person, okay, and we collect the data for whole of India. Now we know average height of India is 5.3 or 5.4. So how is this data distributed. For example, if I say a, I draw a plot where on x-axis the height is there, and on y-axis the number of people for that height. So on a point on x-axis 5.3, you will find that the highest number of people have got 5.3, because that's the average we're talking about on basis of height. So data distribution, so modeling data distribution, we're talking about how the data is distributed across the different values it can have. And believe me, this is the very important topic which I would say you should master, and it will be useful throughout the machine learning sections. Exploring bivariate numeric data. So bivariate numerical data would be when you are trying to correlate two variables, because it's talk about bi and numerical data. So basically, if say height and weight, so height and weight are correlated to each other. Now, how this correlation works, how much a height of a person explains the weight of a person, how much of weight is explains the height of a person. So it does change in one variable makes a change in another variable. So so this is being explained by the exploring bivariate analysis of the numerical data. Study designs. So study design will be talking about the data sampling. So when you'll be looking at the machine learning, you'll see a lot of places we will talking about the sample of data. So for example, when I talked about 1800 records are there in my case study, uh, we we need to see 1800 is not the population of Timor. Timor has got something like 1.3 million people. Now, out of 1.3 million people, we're just talking about 1800 and creating a model based out of it. So, does my data actually has some relationship with the population? Those are sample I'm using should be a true representation of a population. So that's why, and there could be a lot of different ways you can create a sample. So, so that is why this study of design of sampling is also important. Probabilities. All the models, all the working of the machine learning will be talking about probability, because there is nothing as yes, 100% yes or 100% no in machine learning. Machine learning is where machine will be, where you will be teaching the machine, and the output of the machine would be in terms of, okay, I am 80% probable that this is the output. So probability is the key topic, or I'd say is the key core concept of any machine learning, and you should be familiar with how the probability works. Uh, they are one. Sorry, I'm not able to see it over here, but there's called Bayes probability, and Bayes probability is used as a completely like Bayes probability is directly transformed to a Bayes algorithm in the machine learning. So within a machine learning, there is a very specific algorithm which is just based on probability itself. So probability is important. Counting permutation combination, I would say you can skip it, but yeah, for your overall understanding, if you want to do it. But permutation combination is intuitively, yes, it's good to have it, a knowledge of permutation combination, but I don't see it as a mandatory for data science. Now, random variables. Uh, this is important in terms of discrete random variables, continuous random variables, because again, from the sampling point of view, there is a randomness. Until there's a randomness, there is no point of having probability. So how this randomness could be understood, tackled is will be explained with random variables. Sampling distribution. Now again, as when said, sampling distribution is an extension of whole data distribution and then the sample distribution. So how is the population distribution and sample distribution relates to each other? Uh, so that will be explained as part important. Confidence interval. Now this is another important. I would say yes, it would be important, because confidence is something related to probability. So for example, let's say you ask me something and I say, okay, I am 90% confident that the value of this would be 100, but I am 80% confident that the value would be 100.001. So either I can decrease my confidence and go towards the actual value, or I can increase my confidence and basically spread up my probability, like spread up my prediction. So more confident I am, I could have the high range of prediction. So, so confidence level is important. Should go with this. Test, significance test. Now, hypothesis testing or significance testing is something which talks about, okay, I assume, when I said, okay, I've got 144 variables to predict something. Now I have to do a hypothesis testing for each of the variables, saying, okay, does this variable relates to this, does this variable do not relate to this. So hypothesis testing is I'm imagining something and I need to test or prove it. Is this variable related or not related? So yes, hypothesis testing is important. Two sampling in inference for different groups. So comparing two proportion, comparing two means, these are all part of hypothesis, I would say. And yes, these are important. Chi-square test or chi-square analysis is talking about when you're comparing the one categorical variable to another categorical variable. So I won't go in much detail, but yes, this is again important. Advanced regression. Advanced regression is talking about the let's say the explanation of a continuous variable on other variables, and this is important. And ANOVA is again explanation of a categorical variables to the other variables. So yeah, this is the complete course, and I would say, when I said go through this Khan Academy, because I know that this all these concepts are related to machine learning and all will be very helpful for your future journey. So only from all of the sections, I would say only one I've said that, okay, you might skip if you want to, which is counting, permutation, and combination. Though it is an important thing, and anyways, if you're going through all this, I would say do this as well, but maybe keep it on the last stage. Rest all is very important. Yeah. So I think I was able to convey the topics of statistics and probability. And if you go with this book which I've shared, that also contains approximately the same amount of information with a little bit of more, maybe more examples or more in a bookish form. So it's very lengthy to read about. When you go with Khan Academy, there is a 5 minutes, 4 minutes video for each of these topics. And by going through the video, it might be very easy as well. So probably you might like to go by video first, and if you want to go in much detail for a topic, then you can refer to the book as well. So it depends on your choice. So whatever you prefer to go first, you can either go with book or with Khan Academy, or or you just, once you know the topics, you can go to the YouTube, search for it, and go and then get reading from somebody else. But if you are stuck with any point and you wanted any consultation, you can send the query on the group and I'll try to answer it about the any other topic of the statistics or the probability. Right. So at this point, I would say I'm finished of what I wanted to share. If someone has any question or any suggestion, please come forward and ask.
Aniket ji, hi,
Hi.
Divya here.
Yeah, go ahead, Divya. Your voice is a little bit breaking, but yeah, carry on.
Hello,
Yes, Divya.
am I audible?
Yes, he does.
Yeah, and probability seems to be the very
So yeah, I think you're talking about something about probability. Your voice is breaking. I think the internet connection is not so good over there. Is your question about probability being important, or you wanted to ask something within probability? Or you can type your question in the chat as well. So someone else wants to go next for the question. Till the Divya is writing the question. Yes, Divya. So yeah, so you asked this is the groundwork for data analysis study. Yes, this probability and statistics is the groundwork, and this is basically I would say the base foundation as well. Okay, so in terms of summarizing the formula or any of the things, I wouldn't say you need to learn or practice them by hand a lot, but if you do, it's good so that the core idea or the base idea should be that you understand which thing to apply on what data. So until it is clear that, for example, I'd say chi-square. So you know that there will be some test called chi-square, but on which kind of data chi-square test should be applied and why should it be applied? What the outcome of that test would give you and how will it help you? So that understanding is of utmost importance, which you need to gather. In terms of tools, both R and Python gives you the functions or let's say a lot of tools for whole of the statistics or the probability part. So these are, for example, let's again talk about the chi-square or the t-test or different hypothesis testing, which you will learn throughout this. So all these hypothesis testing, chi-square, t-test, everything, be correlation or the covariance, standard deviation, mean, median, everything is there within the languages which you use for the machine learning. But the core would be you need to know what to apply, when and where. I hope I answered your question. Yeah, that's cool. Any more question from anyone?
Aniket, can you go back to your previous case study presentation?
Yes, sure.
So in this, there was one slide where you told us about um, some programming that needs to be done. I'm not sure in which slide it is.
This one I talk about.
After, uh, um, after data cleaning, so there is some programming via some language, R or Python. You told that before this.
So in the cleaning, yeah. So this talk about the cleaning, and you can do this kind of cleaning in anything you want. Either in, I would say, Excel you can also do, or SQL. So the data cleansing or pre-processing can be done in any of the tool you wanted to do.
Mm-hmm.
As part of the exploratory data analysis, you can do this in Tableau or Power BI or ClickView, any of the data visualization tool, you know. Otherwise, R or Python as a coding language also provides a lot of uh, plot libraries which you can use for data plotting and visualization. Like the charts you're seeing on the screen right now are being created by Tableau. So once we have cleaned the data, we have got a proper data which we based on which we can start the study of data analysis uh, from the present representation point of view. So we put it into the Tableau and then produce the chart using Tableau. So pre-processing and everything we did in R, and then we use Tableau for this EDA, exploited data analysis part of thing. Once the exploited data is done, you know what data is about and how you can best use this data. Then comes the predictive modeling or the machine learning part, where you do actual coding in either R or Python. And here you will be putting your data. So if I go with this, yeah. So here you will be putting your data into different algorithms. So the boxes here which talks about KNN, logistic regression, random forest, XGBoost, or neural network. So these are the 5 algorithms in which we put our data and see how each of the algorithm is transforming the data and basically helping us in predicting the output. Now, each algorithm has their own way of handling the data, processing the data, and producing the output. And when I said it's data science, science means experiment. So there is no fixed rule by which you will get the output which you want. You need to do a lot of experimental things. So experimental here is talking about we have to put it into 5 different models. 5 different models will generate the output on their own terms, like how they are, the background in which they're working. So they will be producing their own set of data, which output and how to use that output. You might want to combine this output. So basically here if you see, we're talking about we have got the output from we put the data into 5 models. We chosen the 2 best models, which are the model 2 and model 4, which is logistic regression XGBoost. We combine these output using another model, which is neural networks. In the next box you see there's a neural network mentioned over here. So we the output from these 2 models are being clubbed using the neural network model, and post the neural network model you're able to find out the final output for your data. So this this is a network, and that's why I said it's experimental, because this network is no fixed network. And the person sitting next to me might be producing a different network for the same objective, and his output and my output might differ a lot in terms of the accuracy they're producing. So there will be different parameters on which you will judge between 2 models, either it's a good model or bad model. And it's not probably based on only one parameter being accuracy or how accurate your model is. Your model might be less accurate, a little less accurate from the other person, but it's lot simpler than the other person. Then you might have to choose the simpler model, because more the simpler the model is and better it can produce output. There is no one who will invest a lot in the complex model. So you have to produce a simple model with the particular, at least a level of accuracy which the business want. In our case, the business want to find out, like if there are 5 people, you need to find all the 5 people who have got lung disease. If you're missing upon a people, and saying, okay, you I've been given the data of 100 people, and out of this 100 people, 2 people have got the lung disease. Now I am predicting, or my model is basically predicting, okay, there is only one person who has got lung disease. That makes me think about, okay, I'm making an error saying one person who has got the lung disease, I'm leaving him. And by leaving him, I'm basically saying a person has got a lung disease, and I'm saying him, no, you do not have a lung disease. That's what my model is making a very, very big mistake on a person's perspective, that he will not be given the prescription for the problem which he has already got. So my model has to find out everybody who has got the lung disease. So that is why when we go to the next slide, I say the final model which we have got, this is how we have tested this model. So we have tested it on approximately 400 people. Out of these 400 people, 9 people have got the lung disease, and our model is able to find out all the 9 people have got the lung disease. Plus we are doing some error, because there cannot be a case where there's no error in the model. So we are putting up some error saying 21 people, we are marking 21 people to have a lung disease. So we are saying 21 people, you guys have got a lung disease, although they have not got a lung disease. But still, if you are marking somebody has got a lung disease, that's a, I would say that's a failure of the model, but not a very big failure, because the next step of this analysis would be to actually to actually do some medical test on them and actually find it out they've got a lung disease. So instead of doing a expensive medical test on 400 people, now you just have to do the medical test on 30 people, right? So doing a medical test on 30 people is easy. So and post that medical test, the confirmation can be made, okay, who are the actual 9 people, to find out. So my model is basically helping the government or anybody who wants to scrutinize the people, instead of doing the test on all of them, doing a test on a subset, which our model is picking it up.
Okay. Thanks, Aniket, for detailed answer. Coming back to this slide 20.
Yeah.
So what do we mean by this P4 train, P4 test for like model 2 and 4?
Yeah. As I said, these models, the output of these models are um, mostly probabilities. So probability of a person having a lung disease or not. So P2 test is P2 is the like number two is talking about the second model. So out of the five model, there's the probability coming out of the second model. So P is for probability, two is the number, the numeric number of the model, and then train and test is when you get a data, you need to divide the data into two parts, saying, okay, I'll use, let's assume I'll use 80% of my data in order to train the model. So using the 80% of the data, I will train my machine learning algorithm, and how much better I can make it, I try to make it. And the rest of the 20% data, I'll use it for testing my model, right? So if you start from the most left part, the data is being broken into the train part and the test part. The test part of the data is basically unprocessed, untouched, and nobody is looking at this and trying to cheat. Whatever the processing is happening, or the models you are building, the algorithms you are building, is only on the training data. So training data is the data which is shown to the model, and your models is built on the training data. Once your model is built, then you show your test data and try to see how much accurate your model is doing on an unseen data. Because at the end, this model has to be deployed in live or the data which is not seen by the model. So your model has to be very general in terms, like the model should not be learning too much from the data that, okay, I've got 2000 records. I'll just memorize 2000 records. And as soon as I've found 2000 first record, I'll, I, I may go wrong. So your model should not be too much learning the data, and also at the same time, it should not be too much unlearning the data. So it should learn on a very, as much as generalized way as it should be. And it could be tested by something like, when the data is not seen and you test on it, it will be saying that, okay, this is the completely new data which is being present to the model, how it's performing.
Okay. Yes, anyway, I got your point here.
Yeah, and on the chat, Vivek has asked a question about the prerequisite technical knowledge for learning data science. Vivek, yes, the first prerequisite was to have statistics knowledge, a keen interest in mathematics. Other than that, I won't say that there is anything which should be intuitively there in your system, but your interest to mathematics should be there. Or if you do not want that, but you have very much core interest in coding, then you can just go on the coding part and look from the um, reverse engineering of the code, how your code is performing by changing the variables. So instead of going in the forward direction, what a particular option or a parameter to a function would mean, you go with the coding part first and see by changing the parameter how your model performs, and then you might be able to reverse engineer it. So, I would say, yeah, two paths. If you are very much into coding, go directly to this predictive modeling part. Whatever data you have got, it try to clean it, put it into here, try to change it, try to experimentally work upon it and see how your prediction is coming up on. uh, but if you wanted to go from the front side, which is from the statistics, understanding the data first, and then intuitively building these models, then yeah, you can do that.
Okay.